PowerPointing first and then get on to the demo part of it. So on the introduction to layout command control part of things, why aren't you paying attention to the keystrokes there? Okay, there we go. So, hey.
Nice looking logo.
Settle down. Okay.
Are you finished, John?
I guess I am finished. Okay. A layout command control, LCC. You know, what the heck is it and what's it for? Well, basically, it's for controlling everything that's not a train. So signals, turnouts, block detector switches, lights, the room lighting, the layout lighting, lightings in buildings, animation, level crossings, anything that's electrical, first of all, and is not a train. There are ways of doing it with DCC. There are accessory decoders. I don't know if I've ever actually seen anybody use a DCC throttle to throw a turnout. It seems to be probably the most awkward way imaginable to throw a turnout, but apparently people do a lot of that sort of thing, and we're starting to try to control more and more and more stuff with the accessory feature in DCC. But about 10 years ago, the NMRA decided, you know, this is silly. Better that we have the existing DCC system doing what it's supposed to do from the start, namely just run trains, and have LCC control anything else that you want to have controlled. And I threw the logo in down there. Don't tell Bob Amsler, the NMRA lawyer, that I did that, because it's probably not supposed to be done. But anyway.
I designed it. You can put it on there.
All right, there we go.
Yeah.
So our very own Paul designed that logo. So we have a local contribution to LCC right there. So what would you use it for? So suppose you decided you had a little 3-track yard of some kind or siding or something, and you wanted to have that, you have route control or remote control from someplace else, maybe a dispatcher or something. So you throw some switch machines on the turnouts in there. And then you want a front panel or something. So you have 3 switches or push buttons on a front panel. The little mini layout down at the bottom stands in for the front panel, the fascia. And you may or may not know how you would normally traditionally do that, but you would do it with a whole bunch of diodes in what's called a diode matrix, so that when you pressed one switch there, it may actually throw all 4 turnouts at once to select the right route, because you may need to access tracks 2 or 3 on there, you would have to throw all 4 turnouts to do it. So you would have a whole bunch of messy circuitry in there. Okay, then you want indicator lights to tell you, well, which tracks are occupied, which aren't, and maybe is there a oncoming train from the east or the west that wants to get into this place. So, okay, you have some block detectors. So those little funny looking circuit boards are block detectors. Those are BD20s from NCE. Those are the ones that I like to use, but there are gazillions of them out there and they all look mostly the same. And so you have a bunch of wires running from those to some light bulbs, LEDs, on your front panel there. So you have that. Well, this works well, so you decide to throw in a signaling system. Okay, so you've got some signals there. You really need 6, but I threw in 4. If you've ever tried to do that sort of thing, there's a whole mess of wires coming out of signals. And you would have to have them down, and you have to have something to control the signals. If you're going to use a dispatcher or something, well, you probably want to run that on a computer using JMRI or something. So now you have a computer interface and you have that all there. So, you know, pretty soon you got a pretty good plate of spaghetti going down here. I know this from firsthand experience. There's the plate of spaghetti under the main part of my yard on my layout. And I'm just going to move on quickly past that because it's too painful. Okay, so what's LCC going to do? First of all, it's this kind of a thing that LCC is for. If you just have a few turnouts and a few lights and some switches that control the turnouts or something, I don't really think you need LCC. It's for, you know, automation or any kind of signaling system it would be good for, something that requires a fair bit of wiring. A very small, simple layout wouldn't use LCC most likely, but something like this would. And so what you do is all of these gadgets, they still have the same wires coming out of them as they did before. You can't get away with that. You know, you need, you know, a certain number of wires connected to each of these devices. But what you do is you just hook them onto something local, an LCC node. So you might have one at one end of the yard for all the gadgets that are at that end, and another one at the other end. Another one in the fascia with all of the switches and lights at the fascia connected to it. So all those wires are just right there. You might need another one. And so, okay, you got this sort of situation. Right, but now all of these wires have to be connected to other wires way across the layout or at the other end, or, you know, how does all of this stuff, you have a great big huge bundle of wires going through there? No, what you have is you have one bus wire, a Cat5 cable. Cat5 cables, those are the internet cables. They got RJ45 connectors on the ends, the things that a lot of us use to plug computers into the wall to connect to the internet or into modems or something like that. And they're, because they were so plentiful, they're cheap. They have 8 wires in them, but only 4 are actually used in this system. 2 of them are completely unused and 2 of them are power. So it's really only 4 wires. Well, how does any of these wires connect to any of these other wires using 4? Well, the idea is you don't send electrical signals back and forth. What you do is you send basically what the internet sends, little packets of data. And the data say, oh, that switch changed. And some other node sees that and says, oh, in that case, I have to turn this light on, or something like that. So it's just these nodes connected in a straight line, a single straight line. Can't be branched off or different shapes. It has to be one line like this. You need little terminators at the ends. These little tiny green boxes at the ends are terminators. You need to have something to stop it at the ends. And that's what it looks like. And so how does all of the information flow back and forth on this? And well, here's what happens. So you press this button down here on the panel. All right, number 1, I've been pressed. Okay, the node that it's connected to sees that voltage on that wire connected to that switch. It sees that voltage change, and it says, oh, okay, a button was pressed there. And what it does about it is it tells everybody about it. It sends an event. So this system is all about events, producers, and consumers. So all an event is something that says, hey, that switch was pressed, or that light went on, or that block is occupied, or a train showed up here, or that turnout through, or whatever. And what an event looks like, and what all of the stupid articles get bogged down in, is all of that hexadecimal garbage there. It looks to a computer like 01.5f blah blah blah. You don't need to know what that means. You know, who cares? It's a little event, and it gets sent everywhere. Everybody hears everything. This is what's called a peer-to-peer network. So nobody is in charge. There's no command station. There's no computer that's boss. Every single one of those LCC nodes can produce any event they want, anytime they want, in response to anything that happens. And so it's completely, you know, I don't know, equal among all people. And then, so what happens is, maybe if that was a switch that was meant to select a route on here, maybe the nodes at either end say, oh, hey, I recognize that event. I will set these 2 turnouts the way I'm supposed to when I see that event. And the one at the other end says, hey, that's me too. I need to throw my turnouts as well. So those guys are the consumers. So the node in the middle there is a producer, and the nodes on either end are the consumers. Any node can be produce and consume as much as it wants. You know, each node can produce lots of things in response to lots of stuff happening. So in this one, those block detectors. So 3 out of the 4 nodes have block detectors. They're going to produce events when the train shows up. And almost all of them are going to be consumers as well. So there's an event, consumer, producer. That's pretty much all that is in the LCC standard, as a matter of fact. Everything else beyond that, it is completely open-ended. These nodes can be designed to do anything you darn well want. The trouble is, there aren't very many of them on the market yet. It hasn't caught on all that well yet. The big supplier of these nodes is RR Circuits, and there's another one in Australia. TCS is about to wade in, and there's about 5 or 6 others that sort of are in the, well, I'm trying to develop something mode, but not too much has shown up. But somebody could produce a node that controls signals, that controls anything. There are existing things already that control all that stuff that's on the screen there. There's existing stuff for stepper motors and signals and block detectors and tortoise switch machines and just about all of the standard stuff you can name. Okay, so that's the basics of it. That's the theory behind it. Any questions on that? Unmute yourself and ask a question if you got anything about the basic idea of this. The rest
Would that
of
be for a larger railroad?
Well, mostly for larger railroads, yeah. I mean, what triggered this is great big things like, you know, I don't know, the California State Railroad Museum layout or something that is gigantic, and they wanted to control things such as this, and they were trying to shoehorn it on DCC, and basically DCC broke. So, you know, oh, gee, we need something else. And this LCC is very fast and very capable. The bus that it runs on is called a CAN bus, a control area network. And probably the cars that most of us are driving have one of those networks in it that controls everything in the car. So the cars don't have a whole lot of wiring running all over the place anymore. They just have this bus. And you turn on the headlights or something, it sends an event over to the lights, which detect the event and turn your lights on. So these events being produced and consumed is happening all the time as you're driving your car, as a matter of fact. They borrowed it from that. But yeah, mostly for a larger layout. A little layout with a few simple things probably wouldn't use this.
Good, thank you.
Anything else? Before I move on to a demo, I'll show you one of these things. That's what I prefer to do. Okay, so let me just switch to a different screen here. There might be some lag on here, so hopefully I will go slow enough that you can see it. Okay, so there is a little LCC network, pretty much the smallest one you can have. So the blue wires there that you can see, the blue cables, those are, you know, what you're used to seeing as internet cables. So this guy's got a little cable tied up in a loop that goes over to this middle guy, which has a little cable going over this guy. Those 3 things are the LCC network. This one is the interface to the computer. Oh, I have one more thing I needed to do on the PowerPoint slide. I'm sorry, I left the PowerPoint slide just a little bit too early. The trick here is these nodes have to be told. Well, you know, what events should you produce when this happens? What events should you watch for and do something when you see them? They have to be configured. They have to be programmed. They have to be set up. Well, so you need a computer to do that. It is not practical or even possible to set these things up. That computer, when it's hooked in here, you can program the nodes. Then you can take the computer away, and all of these things will still keep running all nicely, and you don't have to have a computer hooked up to your layout to make it run. It'll run by itself just fine. But to get it set up and to change it, modify it, yeah, you kind of need a computer hooked up to it. So you need some sort of buffer hooked up to it. Okay, I think that's it now. I just forgot that one slide. Let's go back and show this thing again. So this, oops, bumped the tripod. This thing is the computer interface here. And this is just an ordinary USB cable that runs off to the computer. And the middle one, that's a thing from RR Circuits. It's called a Signal LCC. It has 24, is it 24? Yeah, 24 outputs or inputs. 8 of them are perfectly flexible. You can use it for anything you want. 16 of them are only for lights. It's meant to drive signals, hence the name Signal LCC. And it's got some complicated features to theoretically make signaling easy. I have my doubts about that, but anyway. This guy's just a power supply. He's not doing anything except supplying power. And he doesn't even show up as a node. It's technically not a node because it has no intelligence in it. And the little things at the ends with the little green lights on them, those are the terminators. They're nothing fancy. They're just a little tiny thing like a thumb drive that plugs in to a socket to say, that's it, end of the line. So that's the LCC network. And there's my layout. So this guy is playing the role of the entire layout. All I've got is a little board with 2 switches and 4 LEDs on it, and it's hooked into the LCC board over here. And so I'm going to program this thing to do a few things. It's just switches and lights, but you do exactly the same things. If you can understand how to make some lights go off and on when you flick some switches, you got it. You know how to use this thing, because controlling a turnout when a block detector goes off is exactly the same as controlling a light when a switch goes off. The events don't care. It's exactly the same. So I can use this to show you what's going on. Okay, so let's show you what's going on. How you program these things is you need to run Panel Pro. So this is JMRI. JMRI has the two biggest pieces in JMRI are Decoder Pro, which probably a lot of us have used, probably most of us, to fill with DCC decoders. The other one is Panel Pro. You can fire this up and you'll get a window that looks like that, albeit much smaller. It's actually a little tiny window. This looks huge on your screen right now, probably. And you have a menu. This one, depending on your version, might say LCC or it might say OpenLCB. And I should just say a little bit about that. OpenLCB is the group of people on the internet who is developing all this stuff, developing the technical details of all this stuff. They're a very amorphous group. They're not incorporated or formal in any way. Anybody can jump in and throw ideas at them anytime they want. LCC, that's the copyrighted, trademarked NMRA term for the official thing. But OpenLCB is the people who are developing all of the details and feeding them over to NMRA for approval. And so there's some fights about when you use what term. Lawyers are involved, never mind. So OpenLCB, that means LCC mostly. 2 things I just want to show you here. The traffic monitor. So that will bring up a window, and I will bring it up for you, that looks like this. And let me just expand that over. And this will show you those events. So when an event happens, you'll see it. So I'm just going to flip one of the switches on the layout. There it is. And hopefully you can see that the little thing at the end says 4E. If you have to move the people's heads out of the way so you can see that. I wish it wouldn't put all this other garbage in front of it, but blah, 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 blah. The only important part is that the little ending, it says 004E. There's the event, the 02 blah, 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 ending in 4E. That meant that switch just went up. I'll flip the switch back down again. And there's the event that says, hey, that switch just went down. So I'm throwing the switch up and down. I'm getting events. You almost always have events in pairs because, of course, unlike a wire, which is continuously at one voltage or another and is continuously saying, the switch is up, the switch is down, the light is on, the light is off. With this sort of thing, you need 2 events. One to say it changed this way and one to say it changed back again. You always need a pair. Well, not always, but mostly. I'm going to throw the other switch. I've got 2 switches on this thing. So here's the other switch, 5A and 5B are the endings of those events. And those are that means the other switch was thrown. Okay, how did I tell it to do that? Actually, I didn't tell it to do that at all. It came with that by default, but how would I change that or make a different event or who knows what? Okay, so this is a very handy window because it shows you what's going on. You can monitor what's happening. You can debug it when you're setting all these things up. But what you really want is That one, configure nodes, which guess what? It configures the nodes. That's what we want to do here. Never mind about all the other stuff. A lot of this boils down to knowing what to ignore, which is most of it. Configure nodes, though, that's the one you really want. Now, at this point, you get the configure nodes window. I'm showing you a whole lot of different windows here. So this one is saying, okay, here's your LCC network. There it is in all of its glory. I have 2 nodes on it. This first one, hit the little plus sign behind it. You can even see what it is. Oh, this is JMRI Panel Pro. This is the computer. That's the first node. That's the computer interface node. It's saying I'm interfaced to the computer. Okay. And the other one must be that signal LCC. Yep, sure enough, it's the our circuit signal LCC board that's sitting there in the middle. And so you can see what's on your, what nodes are on your network. And then you can actually set up the nodes and configure them. That's what this open configuration dialog says is, okay, let me configure the doggone thing. If I press that, I am going to very quickly zip over to 2 other windows here. What you will see is a whole lot of garbage going by on your monitor. And if you switch over to actually look at the thing itself, here, there are lights flashing all over the place and it's going crazy. And you're wondering what the heck has happened. Did I just short circuit the thing? No, what it's doing right now is it's asking this LCC board right here, how are you set up now? You know, how should I show things to start with? It has no memory of what it saw last time. So it's just downloading everything. This is like if you go into Decoder Pro and chuck a decoder, locomotive on your programming track and say, just load everything in. I don't know what's in this silly decoder, just load everything. You know, locomotive sits there jittering on the track for half an hour. Yeah, that's what it just did. It just did all that stuff. And what you get out of it is this. And you look at that and say, oh my Lord, what is all this stuff? Well, the first thing you do is ignore most of it. So I'm going to take that and just take all of these little down pointing arrows and just click all of them and just get rid of all of this stuff right down to there. Okay, what it really is showing is all the different things you can control, and you ignore almost all of it except for a couple of things. This one's nice. This one lets you give the node a name and describe what the heck it is. If you have a great big layout with a whole bunch of nodes on it, it's nice to know which one you're talking to. So giving it a name is nice. That's no big deal. This is the one you really need. This is the one that controls what the port IO, the IO ports, the pins, the wires that are connected to the thing, what they do. That's the one you need. Okay. So this particular guy has 8 wires. I've only used 6 of them, but there are theoretically 8. And let me just go to line 7. I just kind of hooked them up more or less at random, and I wound up with the very first switch there hooked up to wire number 7. Okay, so line 7 or wire number 7 is actually the first switch. So I could name it as such. That's the first switch. And this is just like Decoder Pro. If you've used Decoder Pro, whenever you change something, it turns orange, and then you actually have to write it into the locomotive in Decoder Pro or the LCC board in the case of this. So don't forget to hit that little right thing. And so that's given it a name. That's nice. And then here's where you say, well, is it an input or is it an output? What's connected to this thing? You should only have normally either it's an output or it's an input. Well, this is an input. It's a switch. It's feeding input into the board. So output, no, nothing. Input, you can say active low or active high and a whole bunch of other things that you should ignore. Active low means tell me about it when it goes low, when it goes to 0, ground, low. And I've hooked all of these things up to be active low electrically. You can wire them electrically to be active high if you want, but active low is more common. And then forget about the delays. You can put delays and you can put flashing lights and you can put all sorts of other things. Here's the only important part. There's the events. So there's 2 sets. These are the events that are look at this little C right down here, that are consumed. Now, I don't want to consume any events. I want to produce them. This is a switch. It produces events. It tells the world that the switch is thrown. Here's the other events. This has got a P on it. So you can produce up to 6 different events, anything you want. And you can also consume 6 events, anything that you want. So the producing, so look at what it says. Event 1, when the input turns on, when the switch goes up, turns on, send this event. Oh, there it is. There's that little 4E that showed up. That's why that little 4E showed up, is because it's right there. Oh, and event 2 then is probably when the input turns back off again, send that 4F thing. Great. I could produce another one if I wanted to. I could say, oh, okay, when the input goes on, also produce one with, well, it's got a 50 by default. I don't know, pick anything I want, 12.34. Okay, fine, I want it to end in 1234. Yeah, write that one in. Now it'll produce a 1234. And it takes effect immediately. If I just go and show you the monitor again up here, and I'm going to flick that switch back and forth again now. Oops, I forgot to save everything. There we go. There we go. It does 4E and a 1, 2, 3, 4. You know, I told it, okay, now produce an extra event. Okay, fine, it produces an extra event. Whatever you tell it to do, it'll do. And so that's pretty much it. The only other thing I want to show you is the opposite. Well, what about a consumer? So let me show you a consumer. Let's go back over here again. And okay, so the first switch happened to be connected there. Where's the first light? It happens to be connected to wire number 5 for no apparent reason. So this is the first LED, or the one on the right. Maybe I should call it rightmost LED. Doesn't matter. So the first light, now this is an output. Okay, it is not an input. Okay, so now I can disable. It's not an input, it is an output, and those LEDs are active low. So steady active low. You can make the lights flash and blink and do all sorts of strange things, but just, you know, active low means it'll put a ground on that pin. And the way I've wired it, I've wired the +5 volts to all of the LEDs, and it's a matter of whether you ground the other end or not. So active low will turn the light on. And there we go. So now it's an output. You may remember the talk that I did on you know, programming on Arduino, and the first thing you had to do is say, you know, pin mode, 3 is an output, 4 is an input. Same thing here. You tell it which are inputs, which are outputs. They all default to inputs because that's safe. It doesn't matter what you hook up to an input, but hooking output up to something that's already producing a voltage, you might fry your chip. Don't do that. Okay, for this one, I want to consume events. So let's go down to the events that are being consumed. And I want to say, okay, now when that switch goes up, here's the big problem with this is you can't just put a name in there. You have to put this stupid string. How do you remember this stupid string? Well, what you do really is you just create yourself a little dictionary, which I have here someplace. I've got too many doggone windows open in here. There we go. I just have a little dictionary here saying, okay, switch 7 up, it sends that, and down, and, you know, make a little dictionary of all of these things. And so I want, oh yeah, when switch 7 goes up, I want to turn this light on. Fine, I'll copy and paste that into my window. So I'll go and copy and paste that in here. Okay, there's the thing with 4E on it. Great. Oh, I better save those other changes as well before I forget. So that'll turn the light on, but it won't turn it off. You need another event. When its counterpart occurs with a little 4F at the end, I'll just change it to 4F rather than cut and paste. Then, oh, and then you have to say what action you want to do. So when I get that little 4E, what do you want to do with it? Oh, I want to turn it on. Write that. And when I get the little 4F, I want to turn it off. And you get your choice of all manner of things you can do with this, but just on off will do. Now I'm just going to write everything. And now, with any kind of luck, let me just flip over to the view of the actual thing. And you don't have to reload it. It's loading all this stuff on the fly. So now, if you look at my little layout here, when I flip switch number 7, the light goes on. Yay! And the switch goes down, the light goes off. Hallelujah, I've invented a wire. Great. So that's, really a trivial thing to do, but it's kind of like programming. The first thing you do in programming is you learn how to write a hello world program. All it does is it prints out hello world, nothing else. If you can write that hello world program, you're halfway to using that language. If you can make a switch and a light work in LCC, you're halfway to producing a signaling system. You just do that many, many, many times. But what you do is just that. Now, there's a little more to it than that. You can get logic into it. So I could program it so that, only if both switches 7 and 8 are up, change light 6 to the opposite of whatever it is now, or stuff like that. You can put little logic bits in it. And if anybody wants to stay away after the meeting, I can show you that. That's one thing. And the other thing is, rather than keeping a little dictionary in a word processor or something the way I just did, Panel Pro itself will keep a little dictionary for you. And that's what this little search button right here is for. If Panel Pro knows about something, you can search for it by name in Panel Pro. And I don't think I have actually anything. So these are weird things here. And if you click that, it'll automatically cut and paste its code in there for you. I want to do that back again. That should have been the 4F thing there. Change it back to what it's supposed to be. I can show you how to do that in Panel Pro as well if you want.